come in from the main room, I want to talk a little bit about our next panel. Our next panel is called Driving Sustainability and Resilience with Digital Twins, and is being moderated today by Zpryme's own Laurel Morris. So please help us in introducing Laurel and her panelists to the stage today.
Playing jokes. Welcome, everyone. Howdy. So, what is the most common and vaguest interview question ever? Is tell me about you. So, could we start with a bit like a 1-minute intros on your fantastic backgrounds and why you think this topic is significant from your perspective? We could go down the line.
You're gonna make me start? Okay. I guess then I don't have to follow anybody, so I guess maybe that's good. So I'm Erin Boyd. I am the Chief Digital Commercial Transformation Officer at AES, which is a global Fortune 500 company that I feel like nobody's ever heard of, and I had never heard of it until they headhunted me 2 years ago, even though I've been in the energy industry for 25 years. So, you know, the long story short about them is we have assets all over the world. We're trying to go renewable, 100% renewable. So I'm a PhD economist by training and a sort of closet data geek, which is why I'm on this panel. So, yeah.
It's hard to follow, closet data geek. Hello, I'm Matt Piper. I'm the Global Industry Solutions Director at ESRI. I lead our infrastructure team. So that's electric, gas, water, telecommunications, and engineering, or AEC. But I'm also our lead on digital twins, so everything to do with digital twins. I'll save you the guess. Yes, it's Australian accent. Been here now for 4.5 years, based out of Redlands, California. Before that was 20 years working as a electrical engineer at a power company in Australia. Relocated over with the wife, 2 kids, and a dog and a cat. And very happy now living in California.
Hi, Thomas Lord. Not a PhD. And not an Australian accent. And you can guess on that, and there'll be prizes later on. I'm in IT, I'm an IT geek. Been in IT since leaving literally high school at 18 years old. So I've been in the profession about 15 years or so. And if you believe that, I can sell you something else as well. Stop there.
So my name's George Hunt. I'm Chief Strategy Officer for SCW. Been with SCW for 2 years. It's an interesting time to be with a company like SCW, who are clearly sort of pivoting a little bit towards the environment and sustainability because of the role and the obligation it's got. Love doing this job. Prior to that, I was General Manager at Sydney Water, where I had 2 primary roles. One was the General Manager of Customer Strategy and Regulation, where we were driving a full sustainability program on behalf of customers, and also driving a regulatory business model that was trying to change the way we operated. The other role I had was CIO, where we were doing a lot of digital transformation. And one of the most interesting things we did, which maybe we get a chance to talk about, was to build a digital twin to protect the environment whilst we're in severe drought, which is an extension of using digital twins for its nominal use, I guess. So thank you.
Thank you. It's a pleasure to have you all here, and I'm curious, because this can differ person to person, but how would you define digital twins? Like, what can people picture in their minds when you say digital twins? And we can start with Thomas.
Thanks. So it's interesting. When I got asked to come and participate, the thing for me that digital twins really exemplifies is the movie Minority Report, where you have the whole thought police and everything, but it's really where they have this replica of exactly what is taking place. And I think they were the pre-crime unit, right? So they could tell what you were thinking before you even did it, and they could get to you before you actually executed a crime. So to me, that's the epitome of what a digital twin would be. And I've always thought it'd be kind of great if I could replicate my business's process, how it executes, and the data it uses, have that modeled, and then get it fed in real time so that you can then picture exactly what is happening as it's happening and take action almost proactively rather than reactively. So that's my career dream. I somehow suspect it will go unfulfilled, but that's okay. Maybe little bits of it I'll get.
I'll go next because I don't want to be the last one to try and answer that question. Digital twins. So Thomas is right, but I think you ask anyone in this room, they're going to give you a slightly different definition of what a digital twin is. ESRI is actually a member of the Digital Twin Consortium. It's a large group of organisations that come together, and one of the hardest things that happened in that consortium was coming up with the definition of what a digital twin is. That was a large body of work, which still seems to be evolving as people's use and applications of digital twins continue to change. But very, very simply, at its simplest form, it's a digital, or virtual representation of the real world. And it could be both the object, the behaviors, and more recently we're seeing the relationships. So a digital twin is not just a static, as you were pointing out, Thomas, it's not just a static replication, but it's actually now a model in context to the natural and built world with these relationships and behaviors. So it gets more and more complicated, but it's really about trying to understand the use case of what you're going to do with this digital twin, and then what do I actually need it for. But now we're seeing this more and more. It needs to be able to simulate and predict and analyze the what-if scenarios. So it's not just about how we operate today, it's about what is going to be happening. And that's probably where we start seeing most innovation right now on the use cases of digital twins.
I mean, I don't feel like I can argue with the consortium definition of digital twins, so yeah.
George, do you have a difference?
I'll argue. So I guess I believe in the same thing that you said, Matt, about where physical meets digital for the built and the non-built environment. If I come to it a little bit more, less from the technology, but more from the impact of having the right platform like a digital twin. The holy grail for the utility companies I've worked for is how do you get ahead of an incident? How do you manage to create time to deal with something before it happens? So if it's an environmental, if it's a sewer network that's about to surcharge into a sort of sensitive area and pollute water courses and things like that, how do you detect that's happening before it happens to give you time to go and deal with it? So the digital twin experience I had that went beyond operational technology with SCADA and telemetry and all the normal sorts of things, and the experience I had was really how do we protect the environment using digital twin platforms by bringing in technology that made it a living model so that you could see what was happening to your sewer network or your clean water network, and you could start to detect we're about to have an incident, let's go and fix it before we have the incident. So buying time and getting ahead of the incident was the goal of this, and digital twins were the perfect answer to building a simulated environment that you could see evolving in real time and using prediction and analytics to get ahead of that.
Yeah, and maybe if I expand a little bit on that as well. I like the impact. I think for me as well, sort of if I put my economist hat on it, what I really like about digital twins is this idea that you can, for lack of a better term, poke and prod it and try and understand what might happen. So almost sort of run different simulations and sort of, say, well, if I poke over here, what will be the outcome? Okay, how might I make that outcome? Is that an outcome I like? Is it an outcome that I need to avoid? What are then the policies that I can put in place? How will decision-making sort of come through? So it is almost this virtual world, but you can also play with it to understand how things might change if you do certain actions or if certain things change. So it does sort of provide that fun really fascinating simulation as well.
So it's interesting because I'm looking at it for like real world applications, and we're looking to do some stuff which I didn't put into the digital twin category until Laurel called and said, there's this digital twin thing. So with the ESRI platform, one of the things that we're trying to do is we're doing a lot of high accuracy GPSing of our physical assets in the field. And so within the industry, natural gas industry, which by the way I represent, we have a lot of underground facilities. And one of the things all of you have heard, hopefully you've heard about 811, call before you dig. Well, every call that we receive, effectively today we have to send somebody out, roll a truck out to the field, and locate where those facilities are using different techniques. So as we go down the path of getting this high accuracy information, what I envision down the road is we're able to, when a call comes in, with exactness understand whether we do have facilities there or not. Because if you do, then you don't roll a truck. And then ultimately, if you could get to it where you now take the information and you have the accuracy in your digital representation, the customer could go and actually do that location themselves. Or taking in another piece of technology that's pretty cool these days, augmented reality. When our technician does go out to the field, they will actually get to be able to see underground, virtually, not X-ray vision, where the substructure issues are. So when they go to locate, instead of today where they're going out and they're like, okay, here's where it's at the curb, and then working within like a 10, 15 foot span to try to find it, they know exactly where it should be and they can check it straight away. So to me, that's one of the values of having that accuracy of the physical world represented in the digital world. So in addition to what if type stuff, actually real stuff. Here's where it's supposed to be. I can see exactly where it's supposed to be with my AR, and yep, it is there.
Yeah, great. I'd love to hear you expand on the stage you're at your utilities implementing digital twins and what specific outcomes and return on investments that you've seen so far.
I mean, I can go first. So I would say at AES, we're in the very early stages of our journey. I think we build large-scale renewable assets. We operate grids. We operate sort of throughout the world. We roll trucks for the utilities. And so we have a really large world of areas where we know digital twins can be helpful. And so trying to just understand what all of our use cases might be, and then start to say, okay, what are the ones that maybe make the most sense? What's the sort of longer term strategy, trying to gather as much information as we can. But I think, one of the things that I'm trying to be very mindful of as well is that I love the idea of digital twins, but also just make sure that I'm not sort of creating a problem for a solution I really want to implement. So, we know that they're going to be really useful. We know we can use them. And so, again, just what are all of the use cases, identifying them. I think, in my mind, I sort of step back and say, I really like the idea of the simulation, but some of the very sort of probably earliest stages for us will be that sort of actual replication of some of our assets. So, if you take a wind asset, so we can put sensors on a wind asset, understand how it's generating in real time, what the performance is doing, what's the weather doing, and that could be everything from, air temperature to wind speed to, you wouldn't think about it, but air density, how all of that is impacting everything about how that wind turbine is operating, and then, building that in that model and starting to then say, okay, what if the air density changes or the wind changes, but maybe it changes at a higher elevation than a lower elevation? How does that change what is being generated? And then sort of circle back and say, how do we maybe site it differently? Or how do we say, okay, based on what we've seen here, now we're going to build an asset over here. how maybe should we sort of measure what's going on with air and all of that over a year and sort of better position it. So it's really about sort of we have massive goals to build renewable assets, and so how do we always sort of make sure that we're being more efficient, optimizing our performance, whether that be just how it's sited, how it's sort of we don't manufacture it, but what we're building, to where certain places that we're siting these. So we're all looking at you, George.
You're the only other utility here. Yeah.
Well, so
Go ahead. Oh, sorry. I'm quite interested in asking my colleagues here about the term digital twin. I feel like it's a temporary label for something else. This is the overlap between my time in Sydney Water and other utilities and my time here at SEW. I think the reason I think it's a temporary term is actually I think what it really is, a digital twin, is a series of connected platforms, with connected layers of information. And it could be, geospatial information or location intelligence. It could be asset intelligence. It could be telemetry on the condition of the operating assets and how they're doing. It could be a customer, it could be weather, it could be climate. Think of it as a series of, showing my age now, a series of CDs stacked upon each other, and you're taking a vertical...
what's a CD?
Yeah, CD. Yeah.
Certificate of deposit?
I didn't say cartridges or cassettes, but imagine a series of CDs that are layers, and you're taking a vertical line of sight through those layers and choosing which bits of information to switch on to provide that digital view of either your operating assets or what your customers are doing or a climatic impact on a certain area of your network. And the reason I think digital twin is potentially a temporary label is because we're moving into a world where the connected platforms are going to be the label that we may apply to this, where we bring in the customer layers, we bring in all sorts of other layers that sit very neatly alongside location intelligence, alongside grid, a 360-degree view of your grid, or your network, and then you bring your customer labels in. So I'm interested in your views.
Well, you've just upset me. We've just finally defined it. We just finally defined it. Now you want to throw the term out. No, George is right. I guess the digital twin notion that you're just talking through, it isn't. Has anyone bought a digital twin? Can you go to any one of the vendors and go buy a product is a digital twin? It doesn't exist, right? It is exactly as you said. It's an ecosystem of systems working together to solve business challenges. There's no one product that does everything that you're going to need to manage the scenarios that you're trying to model and manage a modern grid, modern networks, etc. So to that point, you are correct. But as I said, what's evolving and what's constantly changing now is it is one of those technologies that when you start connecting these platforms, there's always this, oh, now I can do this. Oh, now I want to answer this question. And it just seems to open up more and more doors. I mean, utilities, for as long as I can recall, have wanted to go to 3D, but never really got there in this context of a digital twin being a fully integrated system. But the technology's now getting to that point where now you can start connecting your environmental information models, the weather, etc., your network models of your electric, gas, water networks, your building information models now. This integration back into BIM, this really brilliant 3D modeling that's available now is coming to connected. And then we're seeing this now abstract at a scale that we haven't seen, and it's now bringing all those different models at a city level. And now you can start understanding effectively urban planning and how your infrastructure all comes together. How does your electric grid work with your gas network, with your telecommunication network, work with your water networks, above and below the ground? And that's really where we're starting to see these new sort of ideas coming together about, wow, this notion of a digital twin, it's gone from, okay, I can understand the cogs of a bearing really, really nice, and I can see it in a nice replication, to now at a full city scale for planning, traffic, and the likes.
That's where it gets really exciting, isn't it?
Yeah.
Well, so it's interesting because as George posed us the question, as you can tell, it was unscripted. I'm sitting here thinking it's like, I'm not even seeing a twin. It's because a twin is, by definition, two, for those who didn't know that. I'm seeing a single place where the physical and digital worlds come together and then are used for different things. Because Matt's talking about planning and future stuff. In my mind, I'm thinking about operational stuff. I'm thinking about, can I not roll a truck? You know, we talked about ESG this morning and type 1, type 2, type 3, and everything like that. We're being charged to say, what are we doing to not have to roll a truck if you don't need to? Because all of those things add back into it. And so I'm thinking about this central organism, sorry, you don't have to change your words, which is the combination and it's the confluence of the physical and the digital world coming together that can then be used for multiple different purposes. Mine is operational. How do I do work, execute work more effectively, more efficiently? How do I enable those capabilities to the customer? Because if the customer can self-service, then we have less work that we do, less impact that we have to do, less we have to do. So that's kind of like where I'm thinking. It's I don't know what you call it, but I'll let you guys figure that out. You have a consortium to do it with.
Yeah.
I guess for me, I feel it's a great point. I almost feel, I feel like a little kid in a candy store almost, because, I'm like planning, operations, customer. And, I think this is where then it also becomes really critical sort of when you're an organization and you do have all of these various business lines to sort of say, how do we start to do POCs, and let's not bite off more than we can chew. Let's really sort of understand what the return is and how we want to sort of prioritize, and that's then I almost sort of feel like then that's almost kind of where I struggle a little bit is just sort of there's this whole world that everything we can do, and so it's how do you sort of manage. And I think this is where, as an sort of an organization like AES, where it's really incumbent on us to make sure that we're working with all of the different business lines and really trying to sort of understand and where there are synergies and where we can build the structures that help sort of enable the business to sort of do what it needs to do. That's kind of where I land.
Right. And on that note, are there any departments or groups within a utility that might be overlooking applications of digital twins, and what might be scaring them, and how do you really shine the light on digital twins and encourage widespread behavior change within an organization? George, perhaps, I know you have some experience with this.
So something that really hit me quite hard, I took responsibility for the operational technology as well as the information technology when I was at Sydney Water. And at the time, we were having service resilience issues. We were having asset failures when we shouldn't have that were impacting customers. We were having sustainability or environmental issues as well. We were polluting the environment, killing fish, doing really bad things where the environmental regulator came down really hard on us. And we basically said, how do we build insights here that allow us to sort of detect what's happening within the whole ecosystem that we were looking after, clean and wastewater? And we basically said, we've got to sort of create what became labeled as a hyper-connected utility, which was just a term, but actually what it meant was connected customers, connected workforce, connected assets, very simple terminology. But when you expand each of them, you think, well, connected assets is really an extension of traditional, what you might think of as digital twin. And even when we're building assets, we can utilize BIM to create that information well in advance of trying to retrofit it. So connected assets. And then we start thinking about meters, smart meters, and IoT devices, and you think, well, they're just connected assets. Then you start thinking about connected workforce, where people, and it could stop there. So back to your question, Laurel. In theory, it could stop there, and we could think about it purely in operational or engineering type terms. But actually, I think that the bit where it had highest impact was where the digital platform technology replaced the customer as our telemetry. The issue we had in water was the customer would detect a burst pipe before any of our systems could, And the first thing you would notice is customer sentiment and social media chatter happening. And if you could geolocate that as well, you could see there must be an incident here, because there's an awful lot of chatter about how bad the company is in this area. Or you'd see traffic. You'd see traffic build up because of the impact of a water pipe bursting or something. So in terms of missing departments, what we realized is that it's great to build the operational and engineering dimensions of a digital twin or a digital representation. But where it had really high impact was where you brought the workforce in, where you brought the customer's sentiment and the customer chatter and the customer engagement side into it. And then when you extend that further into the other services around the city, then you do start getting into that really fascinating place of a smart city represented through a digital ecosystem. And it gets really exciting then. So I feel like I need to hand over to Matt now to build on that.
No, I'm sick of saying this, but George, you're right again. No, everything you just touched on there, so what the question I think was, what departments and utilities may be underutilizing digital twins? Well, probably all of them, really, and what's the challenges they find? Well, I don't know, I worked for 20 years at a power company. Data quality seems to be a problem with most utilities. And when you talk about, okay, now we want to run simulations on models of something that's going to help us make better business decisions, understanding precedes action, they don't trust the data. It's like any other reporting system or decision-making framework. If the information feeding it is bad, you're going to get a bad result, and then you just don't trust it. So there's this level of data quality that is required to initially get you started to create these digital twins. That then helps you model it. The advantage in this is, in this connected assets, connected world now, the proliferation of IoT sensors now is bringing back more data than we've ever been able to capture before. Our ability to bring this data in now and run analytics and be smart to help us operate our networks in real time, make better business decisions, is better than what it's ever been. But we do make the assumption that everyone is at the same maturity level on these digital twin curves. And the reality is we still will regularly run into customers and, okay, we just want to take these paper-based forms and convert them to digital. Or, we travel around the world and we talk to customers. Our outage management system is still the customer picks up the phone and calls us to let us know that we have lost power. That's their outage management system. That's as smart as they've got. And so and then the next conversation with those same customers is, yeah, we want to go to the metaverse. And they want to go from point A to the metaverse in one project. And there is this reality of, okay, we need to capture your network, digitize everything, build these relationships, bring all this high volume data in to then create what you're trying to get to. It's not one step and it's not one project. It actually takes an evolution. And most utilities are on that journey in some way or another, and they're moving in that direction. But there is a bit of reality to this conversation that to do this requires really good processes, really good governance, and a good set of data.
And I think for us, the big opportunity I see is coming back to what George touched on, is around our gas and our gas distribution. And so, because I remember going out visiting in the operations area, and the biggest complaint from them is we get stopped by potential customers every day to say, can I get gas? And they cannot answer that question locally within that operating area. They say, well, we'll have to get the engineering done and get back to you. And largely it's because we don't have a very good representation of our gas network. In Pennsylvania, we have over 13,000 miles of pipe, and we know where that pipe is, so we should be able to readily say, if you live within X feet of that pipe, and we know what the pressures are in the pipe, and we know what you're going to have in your home, it's pretty easy calculation. But to Matt's point, we don't have the data. So we don't have that data that coming back to, we don't have the representation in the digital world of what is actually existing in the physical world. And I think that's a big opportunity there, because going out, they're telling me, we got these 12 customers that are all within 100 feet of our main, and we can't turn them on unless we go back to engineering. And then engineering is backed up because they're doing a mains extension. But if you had that information, because it's really what? It's the pipe, it's the distance, it's the hydraulic flow, pressure. And so it's relatively straightforward to do if you have the information. And I think that's the biggest area for us to challenge the opportunity for us.
I think from a in my mind from a just a grand scheme of things, I think the customer aspect could be sort of maybe the last one to maybe come in the sense that, George, I think of your example of, looking at chatter to find areas. I mean, imagine if we prioritized reconnections, based on who was going to complain more. Then, I feel like there's this, when you start to really bring the customer into this, you do start to get into these ethical type of questions where, I can just see the headlines now, where, you connect the people that complain the most faster than you do other people. Or, I even think, if you're trying to sort of say, how might a customer respond? Imagine if my husband made a digital twin of me where he was capturing, and then like testing how I might respond to something, you start to get into these sort of ethical questions around what should we really be gathering from customers in terms of how they're responding and interacting, and how do we then sort of incorporate that back into the modeling and our response. I think the sort of engineering operations is a bit, I don't want to say maybe more low-hanging fruit, but,
So, Erin, all I got to say is if Mary made a digital twin of me and tested her responses on it, she would choose it.
Yeah. I feel like it could work well to make marriages happier.
It'll be more predictable.
I think that's interesting what you said, Erin. The reason we started to monitor chatter and sentiment was because we didn't have a digital representation of the network, and it was the earliest warning we could get of something that was happening that we were unaware of. As we evolved and put more sensors in place, put more technology that's associated with engineering and operations, you started realizing actually the earliest indication of a problem, or the earliest potential of an evolving problem, if you want to get ahead of the incident, whether it's hours or longer, what we found is we didn't have to monitor that chatter. We could start turning it into a different way and start proactively engaging with the customers that might be impacted by something that we detected was going to happen, or we detected it in enough time to stop it happening. So the initial stuff was because we were inadequate in the engineering and operations side. But as we became more capable, we managed to turn the flow of information around from customers telling us to us telling customers, and that was a real game changer. But it was all built on, this idea of a hyper-connected digital platform. Call it a twin, or it's more like a quadruplet. It was more than two.
I certainly didn't mean to imply that you had devious motivations.
Oh no, George well. They were devious.
Having said that, we knew where the MPs, the members of Parliament lived. So if they had we knew we had to respond.
Yeah, I think we can't ignore it. Absolutely, I think it's important, but I think it's the most sensitive.
And another interesting application that we jumped into when we talked before was with EVs, because utilities seem both excited but terribly worried about EVs and the implications of these moving loads that they may not be able to predict. But how can we see digital twins coming in and helping us plan for the future grid with EVs and both day-to-day operations?
So I'm going to cheat and go first.
Yeah.
Did I say I'm in gas? Okay.
All right. I think you just asked this question because you've just been on this roadshow driving an EV around California. This is a question we're getting more and more, actually, from customers, utilities. California alone, I'm an engineer, I like my numbers, but around about 600,000 electric vehicles currently registered in California. By 2030, 7.5 million is what they're expecting, right? That's a lot of electric vehicles on the road, coming home at night. We talked about the Ford F-150 Lightning, this whole grid to vehicle, vehicle to grid conversation. I mean, it's not going to be, just business as usual. Like the grid we have today is going to have to change to how this is going to be the grid of the future. And the scenarios, the modeling, the better understanding of what we need to do, it needs to start now. Like to support 7.5 million electric vehicles requires X amount of charging stations, right? You're going to have them. Where do you put them? How do we reduce this range anxiety thing that every electric vehicle driver seems to, struggle with? Where do you build these EV corridors to make sure you can take those long distance trips? There are so many questions that come into this, and that's just at the residential level. When you level that up and start thinking we're going to electrify every fleet for semi-trailers, boats, trains, what does that do to your grid, and how do they charge at night? It's a completely different model to what we're used to working in now. So when you talk about digital twins, this really becomes, okay, we're solving today's problem, but we need to be forward thinking about these what-if scenarios, these sliding scales to say, what will the grid be looking like? Where are the constrained feeders? Where's the transformers likely to be overloaded based upon these different scenarios that we're running?
Yeah, and I think really then sort of building off of that, I think one of the great things, again, sort of to go back to the simulation, you can start to then say, okay, well, we have some serious problems with this overloading or time. What if we change the economics of the situation, right? How might that change and sort of redistribute or, bring costs down or make sure that, we're not sort of seeing spikes in capacity. So then it starts to get really interesting because you can add that sort of theoretical policy overlay to say, okay, we're seeing problems. What are economic solutions, financial incentives, or motivational things that we can just get to maybe shift patterns so that we're sort of avoiding some of those problems.
You made me think about, do you remember when I spoke to Shuli Goodman on WE3 Live? It was some time back, but she was talking about the grid of the future, and she said the grid of the future is not a grid, it's a fabric. And to explain a little bit more, she said, imagine the fabric that sits underneath a forest, and if there's an area of the forest that is in drought, the fabric under the forest actually moves water to where the trees need it. And she said the future grid is a software-defined network. She was in the Linux Foundation, which is real think tank, and she said the future grid is like a fabric, and it's a self-repairing fabric. So if something breaks, the rest of the fabric will compensate for it in microgrid terms. But also if something becomes overloaded, like you say, Matt, when people get home at night and they want to plug their cars in as the first thing they do, or to switch on their home appliances, the fabric will compensate and move power to where it needs to be. And what I remember most from that conversation was, the future grid is not a grid, it's a fabric, or it's a membrane that is almost living. And I think the evolution of, a digital representation of a physical network is something that is living and can repair itself, or adapt itself, maybe is a better term.
So the interesting thought just came, fabric. If you take a look at telecommunications, I've been in it. When I started, it was like point to point. But if you take a look at the internet now, that's the fabric for telecommunications. And is that kind of like a similar representation to where electricity needs to go? Where it is, you connect to it, but you can go anywhere, and power comes from someplace and goes to someplace, and you got all your micro generation going in there. Thanks for the thought.
Yeah, that's beautiful. I got some chills just imagining that. But it's been fantastic talking to you all today, and the clock is about to hit 0. So thank you all for joining us. And thank you for listening.
Thank you.